Okay, now welcome you all in this lecture. And in this lecture, so far we have completed the concept of a metric or a metric space. We have seen several examples: interior point, open set, limit point, closed set, subspace, and the open and closed sets in the subspace, limit point in the subspace. Now, before closing this chapter, I would like to mention how we can make several MCQs. I have already mentioned all these things, several exercises. Here is, you can see, here are several exercises I have mentioned in my previous talks. So you can see these are several exercises. I have already mentioned that what kind of the exercise. So here you can see that you can start from here. So I have already mentioned that prove that under this condition this is a metric. So and then prove that under this condition this is a metric. And now keep in mind I have already showed that if these two conditions are not enough to make the metric D is the function D is a metric, and then we have proved that this is a metric, and then if D is a metric, then these two are matrices but not this one. Okay, so these are many such kind of exercises, okay, which I have already mentioned in my previous talk. Okay, so this is a metric on K, and this is a metric on Q. Here you can see this is a metric on D, but in the same time, so you can see that this is also a metric on R. This is metric on R, and we have seen that there are many several matrices, and we have mentioned that determine whether the following real valued functions are matrices or not. Okay, so this all these things, so we have mentioned that there are several matrices, different kind of the matrices, and some are not matrices. So you can see that whether the minimum of this and this, maximum of this and this is a metric. I have already shown. But what about the minimum? Minimum is not a metric. I told you that if you can consider this one, you will see that this D is not a metric. Okay. Similarly, so we have several other exercises. So if your D1, D2 are matrices, then the sum is matrix, maximum is matrix, minimum is matrix, this is metric, whether this is true or not. So here is, I have already explained you whether these are the matrices or not. So here you see the triangle does not hold. So for A, B, C, D, you can consider, and you will see the triangle does not hold good. And for example, E, you can see that E also, then the triangle inequality does not hold for this one. So this is also not a metric. So here is I have given several exercises like this one. So these are exercises, and this is a metric. I have already mentioned, and so here you have. So if you have dxy, the metric D is defined in this way, then D is a metric on X union B. Okay. Here is, keep in mind, the important thing is that X intersection Y is empty. Then this is a metric. But if you look here, is D a metric on A X union Y? Okay, which induce X1 on X and X2 on this. So, and this is a metric on R. Okay, now whether this function, like this function, and where P is satisfying these things, is a metric on X. So these are the several exercises which I mentioned in my previous talks. And then similarly here is, you have several exercises here for the bounded set. Okay, so here are several, you see there are several these exercises, and I have already proved all these exercises in my previous talks. I have explained the proof of all these things. And then for the closed sets, open set and closed sets, we have mentioned several things. So these are the examples of interior and closed and so on and so forth. Okay, so this I have already given you. So there are, you can see that this set is open, this set is open, okay, the empty set is open. Okay, so this I have mentioned, and this set, this is the open ball with respect to D and D star are same. This so this you have to keep in your mind. And similarly, you can define, you can see several other exercises about the boundary of A. So these are the exercises which we have already done. So, and now you can see how we can find the boundary of these sets. This I have already explained to you. And with all these things, and then the subspace, here you have, I just in the previous talk I explained about the subspace. So with this remark, with these exercises, now the question, I come to some MCQs. So in this talk, we will see some MCQs. So MCQ based on the metric space. Let us take here is first, which of the following is a metric on R2? So here is, I am taking maximum of this one. Okay, then this dxy is equal to x1 minus y1. X is equal to, is this an element of R2 whose components are x1 and 2, and y is an element of R2 and the component of y are y1, y2. Then dxy is equal to maximum of this and this, and maximum of mod of x1 minus y1 or maximum of, and x2 minus y2. Okay, and then the dxy is equal to mod of x1 minus y1, dxy is equal to x2 minus y2, dxy is equal to minimum of x1 minus y1, x2 minus y1, x2 minus y2. And just I have mentioned, you see that the minimum is not a metric, and this is also not a metric. Okay, so this you can see, I have already given these things in the exercises, and this is also not a metric, but this is a metric as we have seen. So the answer is your A. Okay. Similarly, now how we will check that which of the following is a metric? Now here is, I have already mentioned when I was talking that if you have a discrete metric which is defined as, discrete metric is defined as, you see dxy is equal to 0 if x is equal to y is 1 if x is not equal to y. So this is the discrete metric. Now I explained, I told you in the very beginning that instead of this, if I will replace maybe 100 or 1 over 2 or any other number, whether this D would be a metric or not. You can prove it. It is a metric again with respect to, so if you replace the 1 by any number, okay, any number greater than 0, you will see that it is a metric. So from here you can see that this is a metric. Of course, this is not metric because it does not satisfy the triangular inequality. This also does not satisfy the triangular inequality. This even does not satisfy the first inequality, that x is equal to 0 if and only if dxy is equal to 0 if and only if x is equal to y. Okay, so they do not satisfy the triangularity, and this does not satisfy the first inequality, and therefore the answer is this. So this is a metric. So keep in mind, I just replaced 1 by 1 over 2. You can replace this 0 when x is equal to y and 1 over 2 when x is equal to, when x is not equal to y. So you can do 1 over 2, 1 over 3, 10, 100, whatever you want, you can take, no problem. And then you have, suppose which of the following this is a metric. So here is again, you see this, when x is equal to y, you can see that x is equal to y. So this is equal to, x is equal to y, this is equal to 0. So e raised to the power 0 is equal to 1. So it is not satisfying the first property, M2. Okay, similarly, you will see that this is also does not satisfy the triangular inequality. Even this does not satisfy the triangular inequality. But we have seen, okay, in my talk, previous talk, that the minimum of 1 and mod of x minus 1, okay, is a metric. The minimum of 1 and mod of x minus 1 is a metric. So this is a metric on R. So the answer is your D. Now again, which of the following is a metric on R? So you can take again several things. So here is this B is a metric. So you can prepare these kind of MCQs by yourself. Now you can see which of the following is a metric on R. So here is, I have already told you this is a metric, but rest of the thing, they are not metric. Even then they will not satisfy the first inequality. That is, if x is equal to y, then dxy is equal to 0, or dxy is equal to 0 if and only if x is equal to y. So this will not hold good. Okay, even this one also. So the only thing is that this is a metric on R. So you have to see, you have to click whether the first condition, two condition. It sometimes very rare you have to go up to the triangular inequality. You will find the answer very immediately within first two or three. Just so now I take this one. Now here you have to little bit do something. Here is dxy is equal to x plus mod of x plus mod of y minus x minus y, when x is not equal to y, otherwise it is equal to 0. So it means that if x is equal to y, then it is equal to 0. Okay, so if and only if it is true. Now what about the triangular inequality? So in the triangular inequality, up here it is minus. So because in the triangular inequality, mod of x minus y is less than or equal to mod of x plus mod of y. So here when you put in this minus, then the triangular the inequality will be changed, and therefore the inequality will not hold, the triangular inequality will not hold good for this one. But the triangular inequality will hold for this, because here is the plus sign. So here is the plus sign. So then you can see that this is less than or equal to mod of x plus mod of y. And then you will get the answer. So here is this is a metric on R. But again, this is not a metric on R, and this is not a metric on R. So you can see that even that this here, for example, if you are considering this one. So let us take x is equal to y. So x is equal to y, then this is equal to 0, but this is equal to, no, this is not y. Oh, sorry, x is equal to y, then is equal to, if, you can see that the triangle, even the symmetry. Okay, if you take the symmetry, here you will get y, or here you get y minus x, but y minus x is equal to x minus y, but here you have x, and if you change this one, okay, dyx, you will get y. So mod of y plus mod of y minus x is not equal to mod of x plus mod of y minus x. So here the symmetry does not hold. Similarly, you will not get the symmetry at this point in this case. So you will see that only here in this all the properties of the metric will holds good. Now again you take some other examples. For example, which of the following is a metric on R? Suppose we are taking this one. So whether the triangular inequality holds good here? The triangular inequality does not hold good for this one. And similarly, the triangular inequality does not hold good for this one. Here is the dxy is equal to greatest integer function. Okay, the greatest integer less than or equal to mod of x minus y. And of course, the triangular inequality also does not hold good for because here is x cube for this function. But the triangular inequality will holds good for this one. And symmetries also holds. First set two conditions, this is greater than or equal to 0, x dxy is equal to 0 if and only if x is equal to y, and triangular inequality will also holds good. So D is a metric. So you can see that D is a metric. Okay. And now suppose you are considering, and now I have changed a little bit, which of the following is not a metric on R2. So here is you have dxy is equal to y1 minus y2, y1, y2 plus x1 minus x2. So here is x1, y2, x1, x2 and this one, and this you have to check simply, but here you can see that we have seen that this is not a metric. I have already mentioned that this is not a metric. So if you remember that instead of simplifying, checking all the conditions of a metric for A, it would be very difficult and it will take quite a long time. And similarly for D2, for B, it will take long time to check all the four conditions of a metric. But we have seen in my previous talks that if D is a metric on R2 and X is equal to X1, X2 and Y is equal to Y1, Y2 are elements in R2, then dxy, which is defined as mod of x2 minus y2, is not a metric. But the sum is a metric. You know that this is a metric. Okay, so this is a metric, but this is not a metric. So you have to check. But if you are not supposed to go to check whether they are matrices or not. So, and similarly, instead of this, if someone can also mention that dxy is equal to x1 minus y1, it is also not a metric. So, not only this, so one can write. So, sometimes you can prepare, you can mention several examples, several MCQs by your own. I am just presenting these MCQs because all these MCQs are taken from the exercises which I have already given in my previous talks. So I just extracted all the MCQs, I just manipulate, I wrote in this way, that way, this way, something, and then you will see this here. So if you have gone through all the lectures which I have presented so far and their exercises, then it would not be difficult for you to give the answer of the MCQs. So MCQs are, even you can prepare the MCQs by yourself. As I mentioned that instead of dxy is equal to x2 minus y2, this is not a metric. Even then you can write that dxy is equal to x1 minus y1. It is also not a metric. So this is not a metric on R2. So this was the answer. Now here is now which of the following is not true? Okay, which of the following is not true? And now you see that I have given you that this is what? This is your dxy is less than, this is your triangle inequality. Okay, this we have proved as an exercise. This we have already proved as an exercise. But this is not, we have not proved this anywhere. If you will see all the exercises, you will find that this we have proved as an exercise. This we have proved as an exercise. This is your triangle inequality. It means that this must not be correct. So this way you can see. Otherwise, if you will go to construct an example which does not satisfy this B, it would be very difficult at the time of examination. So you have to check whatever you have studied. So you have to give little bit pressure or little bit you work for your mind to recall what you have studied. And then you will see that we have already proved that this is true. This is also true because you have already proved in your exercise. This is your triangle inequality. It means that this should not be hold good. So the answer is your B. So this way you can give the answer of the exercises. Okay, and then let's take here is some more exercise. Suppose x is a metric, x is a set, and d we are real value such that dxy is equal to 0 if and only if x is equal to y. Okay, so I am considering only dxy is equal to 0 if and only if x. Under which of the following condition d is a metric? Now look here is this is very important. What we are taking? We are taking only dxy is equal to 0 if and only if x is equal to y. And I proved in an exercise that dxy is equal to 0 if and only if x is equal to y. Okay. If you have the symmetry and the triangle inequality, then dxy is greater than or equal to 0. This automatically will follow as we have proved. So we are not worried about the first condition M1. Okay. Now what is left? Left is that if I take this one and any one of the triangle inequality. Okay. And we have seen that the inequality of this type dxy is less than dzx plus dzy. The triangle inequality of this time and this condition both are sufficient to prove that the d is a metric. This we have already done. So the answer is your C. So again, whatever we have done as an exercise, you can treat them not only exercise, but you can treat them as a result. So this is your answer. Our answer is C. Now I have, if suppose D1 and D2 are matrices defined in this way. Again, we know that if D is a metric, then minimum of 1 dxy is a metric, and D is a metric, then this D1 defined in this way is also a metric. So D1, D2 we real well defined in this way. So this is a metric and this is a metric. And we have already mentioned that D1 and D2 both are bounded irrespective of D. Whether D is bounded or not, this we have. Then the question is which of the following is true. Look here is then D1 and D2 are matrices on X. Yes, they are matrices on X. We have already proved. So no need to go for D1 is a matrix but not D2. D2 is a matrix on X but not D1. Neither D1 nor D2 on matrix. So if you have gone through the exercises which we have done, you can very easily, immediately you can say, yes, they are matrices on X. Okay, so the answer is your A. Now take suppose we can write the D1 is defined as alpha times dxy and the square of dsy. Okay, look here is I have mentioned that if you multiply it by the d, okay, then if you multiply it by d, then this is a metric, but the square, because in the square you will not get the triangle inequality. So here the triangle inequality does not open, but this is a metric but not this one. So D1, D2 matrix is no. D1 is a metric on X but not necessarily D2. D2 is a metric on X but not necessarily D1. Neither D1, D2 are is a metric on X. So the answer is your B. This is a metric but not this one. Okay, this we have already mentioned in the exercises. Now, look here is, let D1, D2 be the same as in the previous question. In the previous question means here is D1, D2. Okay, in the previous question, which is the following is true? That is, X is bounded metric with respect to both the matrix D1, D2. X is bounded with respect to the metric D1. X is bounded with respect to the metric D2. X is a bounded metric with respect to the metric D1 or D2. But the first thing is that D2 is not a metric. So we cannot say that whether D2, the space X is a metric, the D2 is not metric on X. So we cannot say anything about the boundedness of X with respect to D2. So forget about the D2 case, this one, this one, this one. So what is left is this one. So it means that X is bounded with respect to the metric D1. Okay. So this is answer is this. Now, for example, again, here you have this question. Okay, let XD be a metric space, D1, D2 be the same as in the previous, and we have the following statement. This is bounded metric space only if this is bounded. No. Okay. D1 is a bounded metric space even if this is unbounded. Yes, this is true. Okay. And D2, X D2 is bounded metric space only if this is bounded. Yes, because if this is a metric, okay, only if this is bounded. If this is bounded, okay, then this is bounded. So here is basically here is where, so this is the answer is your B and C, rest is not. Now here is you have D1, D2 be matrices on a set S. Then we have the following: D1 plus D2 maximum of this and cross. Which of the following is true? A or B? Whether D1 plus D2 is a metric, maximum of D1 and D2 is a matrix, D1 cross D2 is a metric. So this we have proved that A and A, and the sum is and the maximum of D1, D2 are matrices. So this is true. Similarly, there are several examples which we have already seen. So here you have several examples again. So you can convert, you can write all these things by yourself. Okay. Now I take some other, I will go a little fast. I don't want to show you. Here these are, you see that I have already mentioned these, okay, in the exercises, and then the interior point. So here is these are the exercises. Okay, so these are the exercises which I have mentioned about this. Now let's come to okay. So let's say here is if X and D be defined in this way. Okay, then which of the following, whether the dx is a complete metric, so that we will see later because the completeness is not here, so I skip this one here. And if X is the set consisting 2 element, then only one metric can be defined on X. Only 2 matrices can be defined on X. No matrix can be defined on X. None of the above. You see that on every metric, on every set, we can define many matrices, not only 1, 2. Okay, because you can define the discrete metric. And as we have seen that in the discrete metric, dxy is equal to 0 if x is equal to y, and it is 1 if x is not equal to y. Okay, this is the discrete metric, but you can also define dxy is equal to 0 when x is equal to y, and dxy is equal to half when x is not equal to y. Instead of half, you can take any number greater than 0. Okay, then this is a metric. So you can define many matrices on a set. So this is that the answer is part D. Now here you have this, which of the following is not true? Okay, look here is as you see that if X be a set of all real valued continuously differentiable function on the closed interval AB, then the real valued function D, defined as dfg, is the maximum of the derivative of f at x minus derivative of gx. This is a metric on x. Yes, this is given in the exercise, then it is a metric on X. And then this is a metric on X or not. This is a metric on X. This is also given in the exercise. But we have seen that if X is the set of all Riemannian integrable function, then the matrix defined by this is not a matrix on X. This I have given in the remark. Okay, when we defined the CAB and the space of all Riemannian integrable functions. Okay, so if the functions are not continuous, then this is not a metric. So very simple way you can say that this is not a metric. You are not supposed to go through all the to verify all these things. You have to use your memory. Now, the important thing is let D be a discrete metric. What is this set? Here D, the set of all point X in R such that the distance from the point X to 1. Okay, so this is the system to 1 is equal to half. Keep in mind the distance is what? D is your discrete metric. So they are not same. If they are not same, okay, then this would be equal to what? This would be equal to 1, but it is not this one. So X cannot be equal to 1. If they are different, then if X is different from 1, so if X is not 1, then this should be 1. So 1 and it is not equal, so X should not be different from 1. If X is equal to 1, then this is equal to 0. Okay, so 0 is not equal to half. So this set must be empty set. So the answer is your empty set. So this way you can say that the answer is your empty set. Okay, so now I stop over here, and in the next talk I will see several other MCQs related to the metric spaces and open set, closed set, open ball, closed ball, and interior and the closure, and so on and so forth. Thank you very much.